The next machine applies 20 tons of pressure to bend the wires into a basket shape. A robot welds the sides of the basket. A worker then trims off the excess wire. An automated machine bends a piece of wire to form the handle of the shopping cart. They make the frame for the base of the cart, called the chassis, out of one thick tube that's almost 4 meters long. A robot welds the chassis using soldering wire melted by an electrical current. This creates a very strong joint. A die machine punches out casters that'll hold the wheels. They're made of thick steel for extra strength and durability. They spot weld the casters to the chassis. They clean the cart's metal components in a bath of soap and acid. Then they electroplate the metal with nickel, then with chrome as a finishing coat. It's finally time for the cart to take shape. They rivet the wheels to the chassis, then install the bottom rack. The basket comes next. They print the warnings on the plastic panel for the collapsible baby seat. Then the seat goes on, along with the plastic corner bumpers. They print the store's name on the handle inserts. The handle goes on last. After some final adjustments and a quality control check, the newly minted shopping cart is ready to roll. Every machine, from your vacuum cleaner to your car, is made up of a series of parts. Those parts are designed by specialized companies. They first build a prototype, then make the molds or tools needed to manufacture the part. They design the part in 3D on the computer. The computer then guides the machines that construct the prototype. One method divides the 3D drawing into cross-sectional layers just a few thousandths of an inch thick. It feeds this information to a laser that's directed at a tray filled with a light-sensitive liquid resin. The laser's light hardens the resin in the shape of the part, layer by layer, eventually constructing the prototype. They rotate the prototype under ultraviolet light for a few hours to cure the resin. Then they polish or paint the prototype according to the requirements of the design. Another prototyping method works much the same way, but uses a fine powdered plastic instead of resin. The computer guides the laser to melt the powder in the shape of the part, again, layer by layer. They extract the hardened prototype from the unmelted powder. Another method doesn't use a laser at all. The computer simply guides machinery to carve the prototype out of a hard material such as wood composite. Once a prototype is ready, they use it to construct a model of the part out of a very durable resin. They'll use that model to make a mold, then they'll use that mold to cast the part out of metal. The resin model dries at room temperature in 24 hours. Its surface must be smooth or else the mold will have defects. They attach channels that will guide the molten metal into the mold. Next, they fill the model with a mix of sand and a binding agent. They smooth out the surface, then number it for tracking purposes. The sand mix takes about 15 minutes to harden into a mold. Now they can finally cast the part. They carefully pour in the molten metal, in this case magnesium, heated to about 700 degrees Celsius. They block the hole with sand to prevent the metal from reacting to the air. The metal takes about 10 to 20 minutes to harden depending on the size of the mold. They crack the mold open on a vibrating conveyor. They use a plaster mold to cast parts that require a better surface finish. Workers position a box around the prototype to contain the plaster.